All right, there we go. Okay, guys, for 2A, you could have done your whole TN calculation, right? I didn't do that. I was in a bit of a rush, but I'll just add that now quickly. You can also just see that each term is the actual term number, right? Term 1 is 1, term 2 is 2, term 3 is 3, term 4 is 4. All right, so each of them is just a term number. But if you couldn't recognize that, that's perfectly fine. You could have just done this calculation. So you could have said, okay, A is 1 plus N minus 1, and B is also 1, right? The number that you're adding each time. So then you could say that this is 1 plus N minus 1. Okay, which is going just N. That's fine if you did that calculation. Then, like I said yesterday, you can just count. There are 6 terms there. So if you're going from N equals 1 to N equals 6. All right, so those are the number of terms, and then your general formula is just 2. Any questions on that first one? See if I can find one that isn't just like this, where you have to do the calculation. There might be one in that which is still this. Okay, quick now. All right, 4A. So there they're asking me to find the actual sum, remember sigma between the sum. So we're going from R equals 1 to R equals 13. So you could have done that calculation there on the side if you wanted to. Remember we wrote this down yesterday to find the number of terms. It's always the top number minus the bottom number and then plus 1. All right, so this will be 13. If there's just a 1 at the bottom, then it's easy. That's just the number that's at the top. Okay, but if it's a different number, then you have to do that calculation. So you sub in R equals 1 into this general formula to get the first term, R equals 2 for the second term, R equals 3 for the third term. And you see that it's an arithmetic series, right? Because you're adding 2 each time. So then you use the arithmetic series sum formula to find the sum to go to the term. Okay, we just want to write 4A. All right, let's look at, oh, wait, sorry. Here we have B. Okay, so the answer to B was 96. All right, again, if you sub in the values, now remember for your first term, you need to sub in R equals 5, not R equals 1. So if you sub in R equals 5, you're getting 5 for your first term. Then for the next one, we'll have to sub in 6. That will give you 7 as your next term. And then for the next one, you need to sub in 7. That will give you 9. So again, it's an arithmetic series. You see that the difference is 2. And now for the number of terms, right? You take the difference between these two numbers. So 12 minus 5, which is 7, and then you add 1. Okay, so the number of terms is 8. So you use the arithmetic series sum formula to get the sum to 8 terms. Okay, when we move on to the next one, this one might have confused you guys a bit because there wasn't any. Right, but it's fine, we can work with x's. Right, so for your first term, you need to sub in n equals 1. Now, you obviously didn't have to show this step, you could have just written the values down. All right, as the 3 terms, it's fine. I just wanted to show you exactly that I'm making in those numbers. And then, guys, we need to remember our algebra, right? From x squared to 2x squared, we are adding x squared. All right, we need to be able to recognize that. And then from 2x squared to 3x squared, again, we're adding an x squared. So this is again an arithmetic series, but now our first term is x squared and our difference is also x squared. All right, number of terms from 1 to 60, that will be 60 terms. So you could have done that calculation, or just kind of done it in your head, that's fine. So we're finding the sum to 60 terms. Again, we're using the arithmetic series sum formula. Now, in this case, because all of our terms have x squared, does it make sense that when we add all of them together, the sum must also be an x squared term, right? If we're adding x squared and 2x squared and 3x squared, it's going to be a number in front of an x squared. Okay, so there I just simplified that. 2x squared plus 59x squared is 61x squared. And then we multiply that by 50 and we get our answer. Yeah, I'll move down to D just now. D was actually the first one that was a geometric series. All right, D, there we go. So D was asked to go from R equals 0 in your first term, all right, to R equals 13 in the last term. So there, I just subbed in 0 and then 1 and then 2. What did you guys get? Negative 18. Did you have the right same thing? Yeah. Oh, so I just typed it in wrong. Okay. What? Is everything Oh, how did I get this? Maybe I didn't type the negative? I don't know. Yeah, it should be negative 18. Okay, sorry guys, negative 18, and then that's negative 2. So just something that went wrong here. Okay, then, just fix it, it's not the end of the world. Then the ratio is negative a third. Yes, okay. Here we go, sorry about that. Let me actually just erase it now. Negative a third. Negative a third, like that. And that is also negative a third. Like that. Negative a third, negative a third. What's the final answer there? Yes. Negative 13.5. That's the general consensus. Doesn't some people say negative 18? Or were you talking about this as negative 18? Okay. Sorry about that. Thank you. All right, E. Now move on to E. Do we have E? Please tell me something about that. No. Thank you. Okay, 521 over 5. You could write it in decimal. I'm not sure what that is in decimal form. You can just check on the calculator. Okay. Okay, now I must admit I again forgot to do 7 and 8, but I'll do them now with you guys. Sorry. Life is a bit hectic at the moment. Okay, so we are looking for that exercise. Okay, let me just turn this. All right, so I'm looking at that revision exercise, guys, the one that is on Google Classroom, and I said you must do 7 and 8, right? Okay. Just, and guys, on this revision exercise, you probably saw all of the sigma questions on there before I actually taught you how to do sigma, and now you will actually be able to do those. Okay, you guys were day 2 today. Okay, just make sure if you weren't here that you are noticing those dates. All right, 7. They are saying that 2x and y are the first 3 terms of an arithmetic sequence, an arithmetic progression. All right? Then they're saying if the second term is decreased by 1, the 3 terms will form a geometric sequence. So if we have 2 and then an x minus 1 and then a y, then we will have a GP. All right? Is everyone understanding it like that? I'll read that again. They're saying 2xy are the first three terms of an arithmetic sequence. All right? If the second term is decreased by 1, so the second term was x. So now if x is decreased by 1, that's x minus 1, right? Then the three terms will form a geometric sequence and they want us to calculate x and y. What do we know is the same when we have an arithmetic sequence? Okay. Right, so we know that this should be a difference and that should be the same difference, right? But you guys remember that previously, I think maybe the fact that they now said, oh, it's geometric, then maybe that kind of threw some of you off. But remember, they just gave us the first three terms of an arithmetic sequence. We would say that term 3 minus term 2 is equal to term 2 minus term 1, right? Because the difference between these terms should be the same. So for this, I'm going to say term 3 minus term 2 is equal to term 2 minus term 1. Okay, you can write that down as a formula first before we actually sub in those values. So term 3 is y minus term 2 is x. Right, so y minus x, that should give us that difference. But then we are supposed to get the same answer, the same difference, if I say x minus 2. Okay, because they're telling us that it's an arithmetic sequence. So they're telling us that there is a constant difference. But guys, do we notice that this is an equation with two variables? So are we already seeing where this is going? Simultaneous equations, right? So let's sort of make y this up here. I'm going to take this minus x over, and it's going to become plus x. So what is x plus this x? 2x. All right, 2x minus 2. So we already have y as the subject. So we can just sub that into whatever we're going to get. Now this one is going to be a bit more complicated because what do we know about the geometric sequence? We have a constant ratio, right? So we are multiplying by the same thing every time. So here we're going to say term 3 divided by term 2 could give us the same answer as term 2 divided by term 3. No, term 1, sorry. Term 2 divided by term 1. I'm just going to write that there. Term 3 over term 2 should equal term 2 over term 1. Okay, now we can start subbing those things in. So term 3 is y, so we're going to have y over term 2, which is x minus 1. That should be equal to term 2, which is x minus 1 over 2. This is term 1, right? Sorry, that minus 2. Now guys, you can start this in straight away, but maybe we want to just get rid of the fractions first. Okay, let's just make the actual equation a bit simpler. What do we do again when we have an equation with fractions? We times by the LCD. Do you remember that? Because when we times by the LCD, we'll be able to cancel out both of those denominators. So the LCD is going to be 2 bracket x minus 1. Right? So this we're going to times by 2 bracket x minus 1. And that we are going to times by 2 brackets x minus 1. Remember though that in the second fraction we have 2 terms already. So let's put brackets around those 2. Because whatever we're multiplying by this, we need to multiply by both terms. Okay. Then this is quite nice. In the first fraction, do we see that the x minus 1 will cancel off the x minus 1 at the bottom? Okay, we will be left with 2y. Okay, from the second fraction, the 2's are going to cancel out. I'm left with x minus 1 times x minus 1. You can write x minus 1 squared if you want to, but we are going to FOIL those brackets out anyway. All right, so now we can start this y now. Okay, this is probably the point where I would do that. So now I'm going to say that y is 2x minus 2. So I'm going to do 2 times 2x minus 2 is equal to, now I'll just FOIL those out, x squared. We do the outwards, we get negative x. We do the inners, we get negative x again. And then the last negative 1 times negative 1 is plus 1. Okay, so then we're going to do 4x minus, we have this left, good, thank you. So 4x minus 4, that is x squared minus 2x plus 1. Right, did everyone still with me? So after this, it's basically just algebra, right? Just getting to solve for x. So we have x squared. Here we have a negative 2x. If I move this 4x, it's going to become negative 4x, so that will give me negative 6x, right? And then I have a plus 1. If I move this minus 4, it's plus 4, so that's going to give me plus 5. You guys can see that I just put the x's on the left-hand side. Now basically just swapping the two sides around. And now can we factorize that? Factor the 5 and the sum is gives me negative 6. Negative 5 and negative 1, right? All guys, remember you can use the quadratic formula if you want to, if you forgot how to factorize, that's fine. So I'm saying negative 1 and negative 5, because negative 1 times negative 5 is positive 5, but then negative 1 minus 5 is negative 6. Okay, so that's why I chose those numbers. So then from this first bracket, I'm going to get x equals 1. And from the second bracket, I am going to get x equals 5. Now I need to match these two up with their corresponding y values, right? So if x is 1, y is going to be 2 times 1 is 2 times 1 is 2 minus 2 is negative 1, right? You can show that substitution if you want to, but you won't get a separate mark for that. So you can just do it either on the calculator or in your head. And then when you are doing x equals 5, y is 2 times 5, yes, it's 10, minus 2 is 8. Okay, so those are the two answers. There are two options for x and two for y. Yes.
Ma'am, I didn't try the Chinese with
Okay.
I got it correct.
Yeah. As long as you got two answers.
Yeah, that's fine. Maybe like I made y 2 plus 2.
Yes. Yeah, for this y value, I'm starting it anyway. So 2 times 1 is 2 minus 2. Oh, sorry. Oh, it should be 0, hey? No, it should be 1. 2 times 1 is 2 minus 2 is 0. Is that what you're saying? Yes, thank you. There we go. Sorry. Okay, so when x equals 1, y must be 0, and when x is 5, y is 8. Now let's quickly check if that actually works in the two number patterns that they gave us. All right, so they're saying if x is 1, y is 0. So that would mean that this is 2, 1, 0. Is that an arithmetic sequence? 2, 1, 0? Yes, hey, I'm just minusing 1 every time. Let's see if it works here. So x is 1, so this is going to give you 0, and then 0 again. 2, 0, 0. What's happening there? Counting by 0, hey. Okay. So that's give us a GP. The next one, x is 5 and y is 8. 2, 5, 8. Does that work? Adding 3 every time, hey. And again, if x here, the x is 5, so this will be 4, and this will be 8. So 2, 4, 8. Is that a GP? I'm multiplying by 2. Okay. That does work. All right, any questions on this one, guys? The algebra, obviously, you just need to be able to solve for x and y there, but it was basically just being able to set these two equations up by using things that we've done separately that is now put together into one list. All right. Okay, 8. Seems like it was a bit of a long one. All right, so for 8a, they're saying 12 and 3 over 2. Okay, wait a minute, I'll write it like that, sorry. They're saying 12 and 3 over 2 are the first and fourth term of a particular sequence. All right, so term 1 is 12, and term 4 is 3 over 2. Now in 8a, it is saying we must find the second and third terms if the sequence is arithmetic. Right, so if it's an arithmetic sequence, we're going to have to work with this formula, right? A plus n minus 1d. Okay, so term 1 is 12, that means that a is 12, right? And then term 4, if we need to write term 4 using this formula, we're going to say a plus 4 minus 1d. So a plus 3d is equal to 3 over 2. Now we're going to put that 12 in there, so we're going to say 12 plus 3d is equal to 3 over 2. Right, and now we just need to solve for d. 3 over 2 minus 12. Okay, now we need to divide by 3. Negative 3. Okay, so negative 3.5 basically. So guys, again, maybe because they worded it slightly differently, it might be confusing, but we've actually done so many of these types of questions. So they give you the values of two terms, and they are telling you it's an arithmetic sequence or a geometric sequence. You need to find some other information, right? So if they are giving you term 1, that's always a, regardless of which type of sequence it is. Then term 4, they're saying it's 3 over 2. They're telling us that it's an arithmetic sequence, so we need to use the arithmetic sequence term formula to rewrite term 4 as a plus 3d. And then we just put that a value in and we solve for b. Right, now they asked for the second and third terms. So if we have that term 1 is 12, then term 2 is going to be 12 minus 7 over 2. Right, so 12 minus 3.5, so that's 8.5, right? Which is what we get, that's 17 over 2. Yes? I have to redeem myself now after all my mistakes. Okay, and then term 3 is going to be that, right? Term 2 minus 7 over 2. I think we can do that. That's 10 over 2, which is 5. Of course, you can just use your calculator for this. And guys, you don't have to write this step down. I'm just showing you exactly how I'm getting these values. You can just do that on the calculator. 12 minus this, right answer, and 2. That minus 7 over 2, right answer. Okay, that's 8a. 8b is the same information, but now they are telling us that it is a geometric sequence. So now we need to just use the other formula, the geometric term formula, term n formula. So if term 1 is 12 again, that is still a. Remember, a is term 1 in both of those formulas. And term 4 is 3 over 2. So now if I need to express term 4 using this formula, it's going to be AR to the 4 minus 1. So AR cubed. And we know what A is. A is 12. So 12 R2 is 3 over 2. Can someone tell me what 3 over 2 divided by 12 is? Okay. What? Oh,
1/8.
1/8. Okay, thank you. Sorry, I was supposed to say something. All right, and now we just need to cube root that, right? What is the cube root of 1 over 8? 1 over 2, right? So that is the ratio. So we are multiplying by a half every time. So therefore, term 2 is 12. Term 1, right? Times a half. Again, you don't need to write this calculation step, but I am just writing it down. So that is 6. And what's the next term going to be if I do 6 times a half? 3, hey? And guys, will I get 3 over 2 if I now take 3 and I multiply that by a half again? 3 times a half is 3 over 2, right? So you can again check whether that actually works. Okay. I am not going to be doing, excuse me, here. I'm using new with you guys. I just want you to practice on more segmentation stuff. So you can just write this down. And guys, then we have one more topic and then we're done with this section for this chapter. So we'll do the last topic tomorrow. What's today? Wednesday. Yeah, we still have to just do an example on the brackets again. This is stuff from last year. No, we're doing class 2. Guys, have I given you anything out of the checklist on exercise before? Have you got any questions on that? Okay, keep going on that, please. Examples like this. So I'm just going to put it on the board and then we can talk about it. Just to give you an idea of how to get started. All right, so I'll put those questions just up now again so you can copy it out. But here we have 3B. This is the first one that you have to do. Yes. All right, so for 3B, they say now determine n in each series. Now, what are they telling us here, guys? They're saying that the sum from where r is equal to 3 to where r is equal to n. All right, so they're not telling us how many terms, right? That's what we're going to have to figure out. 6r minus 1. Actually, maybe I shouldn't give you b because there's a 3 there. I'll cross out b. Don't do b because that's a bit complicated. Let's start with c rather. So from r equals 1 to n. All right, so we need to find the number of terms. This is the general term of the number pattern. And they say that it's equal to 44. Now, what is this 44? It's the sum, right? Because they're saying that sigma, the sum of this whole number pattern, which we can find term 1, 2, and 3 of, right? Just like we've been doing all the other questions. We're going to find term 1 by subbing in r equals 1. Term 2 by subbing in r equals 2. Term 3 by subbing in r equals 3. Then from there we can see, is it an arithmetic series or a geometric one? What is the a value? What is the d or the r value? The sum is 44. Right, so we're going to sum everything into the sum formula, the correct sum formula based on what type of sequence this is or series. And the sum is then equal to 44. The only thing that should then still be a variable in that whole sum equation is n. Okay, and you can then solve for n from there. So that's what you need to do in all of these questions in number 3. So sorry, we're not doing B. We will do C and D. Let's do A, C, and D. So we're just replacing B with A, please. All right, please fix that. Sorry. I just had R equals 3 at the beginning. Okay, number 1 in the check your skills question is just like the one done before where you must just find the sum. And then number 6, I forgot how it is. Number 6 is like number 8 that we just marked. Okay, well, they're giving you some information. You must find if it's an arithmetic sequence, you must find an answer. If it's geometric, you must find an answer. Okay. So that is your work for now, please. And it turns into homework if you don't finish it before the end of this lesson.